All right, welcome to Unit 1 quiz review. So the first thing we're going to look at is this cathode ray experiment. And in the cathode ray experiment, I have a little write-up here. It says, the first important experiments that led to an understanding of the composition of an atom were done by the English physicist J.J. Thomson, who studied electrical discharges in partially evacuated tubes called cathode ray tubes. He found that when voltage was applied to the tube, a cathode ray was produced. See Figure 1A. So Figure 1A is right here. If we go down to the bottom, it says because the cathode ray was produced by the negative pole of an electric field, he hypothesized that the cathode ray was a stream of negatively charged particles. Figure 1B, this is Figure 1B, shows an experiment that J.J. Thomson used to test his hypothesis. So I have some questions associated with this, and I want you to answer these questions. And I have some choices, so I'm going to magnify those. And so take a minute to answer these three questions. Okay, so in the next part, we have Ernest Rutherford conducted the gold foil experiment by directing alpha particles at a thin sheet of gold foil. Rutherford reasoned that if Thomson's plum pudding model were accurate, the massive alpha particles should crash through the thin foil like cannonballs. A particle representation can be found in Part B of Figure 2A. So here is Part B. So this is what we're going to be looking at. So I have some questions here. I want you to answer these questions, and I'm going to give you some time to do that. Okay, the next part, we have some Bohr models. So with the Bohr models, you have choices A through E. I want you to answer questions 1 through 4. So I'm going to give you some time for that. Okay, and then I have another question here. Why is helium in group 8 instead of group 2? So you're going to choose the choices for this one. They will be listed in the Edpuzzle quiz. And then next, I want you to answer these questions based off of element X. There's element X. I want you to try to answer those questions. The choices will be available in Edpuzzle. Okay, on the next part, you're seeing an orbital diagram, partial orbital diagram of chromium and copper. I want you to answer the 3 questions, and the choices will be in Edpuzzle. All right, in the next section, I have some questions. The first 2 are having to deal with the chart right here where it says salt and actual flame color. I would like for you to answer these questions in Edpuzzle at this time. All right, and then next, I would like for you to answer these 3 questions. All right, and then lastly, all I would like for you to do is consider the chart, and I would like for you to tell me which atoms are in the mixture. So make sure you choose all that apply. Okay, so we went through everything, and you had an opportunity to answer the questions and kind of gauge where you are before. And so now we'll go through these together so that hopefully we can pick up on any misconceptions that you may have had. So when we're looking at the first part, it's very important that you're following the figures that you're asked to follow. So if I ask you to look at figure 1A or figure 1B, you need to make sure you're looking at the proper figure. So there are 3 types of questions, and these are referring to figure 1B. What did he observe that made his hypothesis valid? So in figure 1B, we can find the choice. So his hypothesis was centered around that the cathode ray was a stream of negatively charged particles. So we are looking at a response that will validate his hypothesis. And the one that will validate his hypothesis for number 1 is going to be letter C. The ray bent towards the positively charged plate, and because opposite charges attract, the ray must contain a negatively charged particle. And that's really the meat and potatoes of what you need to know. If you see this ray bend towards a positive plate, and that's a positive plate, then what's in the ray must be negatively charged. Also, we see that this plate is negative, and so it is repelled by the negative plate. It is attracted to the positive plate. So opposite charges attract. All right, opposite charges attract. Whoops. Okay, so, and like charges, not exactly sure what's going on with the pen. Anyway, like charges repel. And there must be some kind of, there we go. It probably works now. And like charges repel. Opposite charges attract. We had a little glitch there for a second. Okay. How could he conclude that a negatively charged particle is found in all atoms? So you have to find a choice that would match that question. And so if you have something that says how can he conclude that it's found in all atoms, then B is going to be our best choice, because no matter which element he used in the ray, the cathode ray was produced. So he could have used any type of element and he gets the same cathode ray with that negatively charged particles. So you can conclude that all atoms contain negatively charged particles. And then lastly, how could he deduce the presence of a positively charged particle? Well, that is obviously going to be our last choice, and that is going to be that atoms have a neutral charge, or a charge of 0. If the atom has a negatively charged particle, then it must have a positively charged particle in order to have a neutral charge. So if you have a plus charge and a negative charge, that's going to equal a 0, a charge of 0, because those two things cancel out. And we seem to be having some glitches with the system, so it won't let me write. All right, we'll move on. I think we answered those questions. So, yeah, they will cancel. So if you have a plus sign, 2 pluses, and 1 negative, that's going to equal a 1 plus charge. And then if you have 1 plus and 2 negatives, that would equal to a 1 minus charge. So 1 plus, 1 plus, and that is because those cancel, and those cancel. You're left with a negative, you're left with a positive. Here you're left with nothing, so you get a charge of 0. And that is the idea behind if there's a negatively charged particle, there must be a positively charged if the atom is neutral, and they knew that the atom was neutral. Okay, hopefully we don't have any more glitches. Then we look at the second part. It says that it's the Ernest Rutherford gold foil experiment. We're really looking at part B of this experiment. So if we look at that, we will notice a couple things, and let's see if we can't get the right answer here, or answers, depending. So use part B of figure 2A. Using part B of figure 2A, which observation can be used to conclude that the nucleus, and that really should say, has a large mass? So what is allowing us to know that the nucleus has a large mass is that when the alpha particle hit the nucleus, all right, and it hits right here, it changes direction. And another word for saying change direction is deflect. So then alpha particle deflected. So we have to find which choice shows that? When the alpha particle hit the nucleus, they deflected or changed direction. So that is going to be choice C. So 1 is choice C. All right. Then the next one says, using part B of figure 2a, which observation can be used to conclude that the nucleus is small? Well, most of the alpha particles miss and pass straight through the foil. And if they miss the nucleus, they miss the nucleus for a reason. It's because the nucleus is small. All right, so that is our choice there. The other two choices, the alpha particles do not change direction when it hits the nucleus. That is not something that we observed. We see that when these alpha particles hit the nucleus, in both cases, that they definitely change direction. So that is not true. And then it also says on part D that the alpha particle hit the nucleus most of the time. That is absolutely not true. If you look at this, 1, 2, 3, 4 times it misses, and then 2 times it deflects. So this is just a small scale model, but most of the time in this model, they miss. They did not hit the nucleus most of the time. So you cannot make that claim. All right, and then we get to this next part, and it talks about the types of questions for Bohr models. And the first question is, which atom or atoms has a mass number of 10? So what you should see there is the mass number. Maybe I'll get a different color. But mass number is equal to the number of protons plus neutrons. And so we should see that 5 plus 5 is 10, and 4 plus 6 is 10, and none of the others get us there. So for part 1, this will be choice A plus B. It also asks us, which is beryllium? Well, you have to go to your periodic table. I don't have one listed here, but go to your periodic table, and beryllium has 4 protons. So you're going to find which of these has 4 protons, and you should find that right here. Choice B has 4 protons, so that is going to be B. And then which atoms, and there have to be different atoms, all right? We don't want the ones to be the same, are in the same group. What you should know is that atoms with the same number of valence electrons are in the same group. So if you look at choice C, it has 1 valence electron, there it is, and choice E has 1 valence electron, and they're both in group 1. So our answer here was choice C and E. All right, and then also, if you have atoms in the same group, I want to make sure you know this. Atoms in the same group will react alike. Make sure you know that. So atoms in group 1 will react very readily. They're highly reactive. And the opposite atoms in group 8, they will not react very readily. So, okay, let's look at number 4, which atoms are isotopes of one another? Well, isotope, they're atoms of the same element. Which 2 of these are atoms of the same element? So look at choice A has 5 protons. Choice D has 5 protons. They're both atoms of the same element. So they are isotopes. And so you have, and I don't even know, I need to know what that element is. I know they're isotopes because they both have 5 protons. They're the same element. So that would be choice A and D. Okay. Now, we get to a very interesting question. So if you notice, helium is in group 8 and neon is in group 8. But if you look at neon, we see that it has 8 valence electrons, and helium has 2 valence electrons. So why are they in the same group? And the answer lies in the electron configuration. Helium, its electron configuration is 1s2, and neon is 1s2, 2s2, 2p6. So if you look at the s orbital, it can hold 2 electrons. And if you look at the s, it holds 2 electrons, and the p holds 6 electrons for a total of 8. For a total of 8 electrons. So neon, its second energy level has both the S and the P, and it has 8 electrons, or it's holding as many as it can, so it has a full valence shell. But so does helium, because it has the S and it does not have a P, but S can only hold 2 electrons, so it too has a full valence shell. And because they both have a full valence shell, they react alike. And that's why they are in the same group. Okay. The next part, I put 2 of these in here. What is the average atomic mass of magnesium? And that does not need to be there. The average atomic mass of magnesium, if you look at this, you will find the center to be 25. And if you were thinking of this as kind of a scale, and you had a board on this, which of these would weigh it down more? And you would say 24 would. So your answer should be something really close to 24. In fact, it is 24.3 AMU. So you could guess that, or you could simply do the math for each of these isotopes and say 24 times 78.99 divided by 100 equals blank. 25 times 10 divided by 100 equals blank. And 26 times 11.01 divided by 100 equals blank. And you could add those all up and you will get 24.3. So there's 2 ways to do that. And then I ask another question. How many isotopes of magnesium are represented in the mass spectrum? This is probably one of the easiest questions. If you look at this, you have 1, 2, 3, 24, 25, and 26. So there's exactly 3. And then I ask how many neutrons are in magnesium 25. Magnesium 25 is magnesium with a mass number of 25. So if it has a mass number of 25, that means it has 25 protons, not 25 protons, but 25 protons plus neutrons. So if we added our protons plus neutrons, it would equal 25. So if we subtract the number of protons, and magnesium has 12 protons, then we should get 13 neutrons. And so that's how you get that. All right, and the next part says, what is the average atomic mass of element X? So you could do the same thing that we did before. You find the center between 41 and 49, and you'll see that that is 45. And if you tip the scale, you're going to have 44 on this side and 44 on this side. And so you are not going to tip the scale. So the average is going to be 45 AMU. And again, you could take your mass number. So as an example, I'm not going to do all of them, but as an example, you could say 41 times 22 divided by 100, and you can get your values there. Do the same thing for 42, for 43, and so on and so forth. And you will come up with 45. And it says how many isotopes? There's 1, 2, 3, 4, 5. 5 isotopes. If element X has 22 protons, how many neutrons are in the nucleus of 45? You have 45 minus 22. That would give you 23 neutrons. All right, and then the last part, using your periodic table, identify element X. So we go to our periodic table, and we know that we are looking for 22 protons. We find 22. That is listed right here with, I don't know if I can expand it. I can't expand it, but it is titanium. So you should be able to see that. Okay, so that would be Ti. Okay. This one asks you to write the full electron configuration for chromium, and this says expected. So you're only seeing 3d4 and 4s2 on your orbital diagram, and when in fact it starts at 1s. So what you would have is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. And that's how you would write your electron configuration for chromium. And that is chromium. And then for copper, it would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. So this is chromium, and that is copper. All right, and if you did the observed, what you will notice is that chromium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. And the reason, so what's happening here is this is no longer 4s, I don't know what's going on there. This is no longer 4s2, it's 4s1, and it donates an electron to make that 3d5. And the reason is that it causes the atom to have lower energy and to be more stable. And so that's the reason why that happens. Similar, and it's more stable because if you look at our orbital diagram, this has a 1/2 filled orbital, which is said to have lower energy and be more stable. So that's what you're really looking at. So, and if you're looking at copper, you have 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. The same idea here, but now this causes it to have not a half filled, but a full orbital. And so, but it will cause lower energy to be more stable as well. Okay, and I think I answered question number 3 over here. Okay, and then the last part, well, maybe it's not the last, we have a couple more in here. I said, these are the types of questions. So here you have this chart, and it talks about sodium chloride, potassium chloride, calcium chloride, strontium chloride, lithium chloride, copper chloride, and copper 1 chloride in particular. So this should be familiar with you because this is what we did in our lab. It says which salt will produce a flame with the shortest wavelength. So what you're really looking at here is the color. All right. So where is the shortest wavelength is going to be something with violet. And do you see anything that has violet or a color close to violet? And you would see that that would be potassium. All right. And so that falls over closer to this range. And because we said shortest wavelength, that also means highest frequency. So our answer here is KCl. And it says which salt will produce a flame with the lowest frequency. Well, what has the lowest, which color has the lowest frequency? And what you should see here is that that is red. Do we have anything that has red? And the answer is yes. So we see strontium chloride. And so of those choices that we have, SrCl2, and if it also has the lowest frequency, it means it has the highest wavelength or the longest wavelength. Okay. That's an easy one to answer. And then another easy one to answer is we ask some questions about the electromagnetic spectrum and says which type of electromagnetic radiation has the lowest energy. We should know that energy and frequency are directly proportional. And what that means is when energy increases, so does frequency. So if energy and frequency go together. So which type has the lowest energy? Well, it's going to be the one with the lowest frequency. And so that will be radio. The one with the highest energy would be gamma ray because it also has the highest frequency. Which color in the visible light spectrum has the highest frequency? Well, look, frequency is increasing this way. So violet is going to be the one with the highest frequency, so violet. And then which type of electromagnetic radiation has the longest wavelength? And here that was going to be radio. So if you notice, two of these, radio, are in question 1, has the lowest energy and the longest wavelength. That's because energy and frequency are inversely proportional to wavelength. And so that's that. My handwriting may be terrible, but they're inversely proportional to wavelength. So when energy and frequency increase, wavelength decreases. Okay, and then this last part, we did a worksheet on this. All basically you're doing is checking to see what is in the mixture, and you're seeing if the spectra, the wavelengths that are found in lithium are matching up with anything in the mixture, or cadmium is found in the mixture, strontium is found in the mixture. So you find the lines and you see they match up, they match up, they match up, they match up. So the mixture contains lithium. If you look at cadmium, you see there's 2 lines here, nothing there. Does not contain cadmium, so that is an out. And then if you look at the next one, we have strontium, matches up, matches up, matches up, matches up, matches up, matches up, matches up. And so it also contains strontium. And that's how you do that. Anyway, I hope that this will help you score very well on your test. Wish you the best of luck, and thank you for watching.